This will be part one on chapter test on derivatives. So if you want to test your knowledge on derivatives, uh, you came to the right video. So let's start with question one. We have y equals secant of x times tan of 2x, and we want to find y prime. So if you look at this problem, what derivative technique should we use? Well, we're multiplying two things, so most likely the product rule, right? So if you recall, product rule is f prime of g plus g prime of f. And what I would do next is find my f and my g. So my f, so this could be my f, the secant of x, and then the tan of 2x will be my g. Okay, so f prime, what's the derivative of secant x? The derivative of secant x is secant x times tan of x. And then g prime, the derivative of tan of x, the derivative of tan of x is secant square of x, but because we have a 2x, we got to use the chain rule. So it's going to be secant square, and our x is 2x. Then you apply the chain rule. So what's the derivative of 2x? 2. So you can put that in front. Okay, and then you just apply the product rule, and you're good to go. So f prime is times it by g. G is tan 2x plus g prime, which is 2 secant square of 2x times f, which is secant of x. Okay. Um, so if you kind of clean this up, you can rearrange this as this part right here could be expressed as secant x. And then this part right here, uh, you could just leave it as it is. There's nothing there's nothing you can simplify. Now, is there anything you can factor? Yes. It looks like they all have a secant x, so you can factor a secant x. So this would be y prime. Okay, so this is your final answer. Let's move on to question two. So we have question two, we have f of x equals log base 2 of x5 plus ln of sine of x, and we got to find f prime. So what technique shall we use? Well, we could just take the derivative of each term. They're not squished, so we don't have to use the product rule. So we just have to take the derivative of log base 2 of x5 and then the derivative of ln of sine of x. So let's start here. What is the derivative of log base 2 of x raised to the 5? Well, the derivative of log, not to be confused with logarithmic differentiation. So if you have a log to a base of x is equal to 1 over x ln of a. So it looks like our x is x5. and my base is 2. Okay, so we can say f prime of x is, so for this, it's 1 over x ln of a, so it's 1 over x, and my x is x5, and then ln of a, like that, plus, now what is the derivative of ln of x? Well, I know the derivative of regular ln of x is 1 over x times the derivative of x prime, right? Which is really 1 over x. So it's the same concept. It's just that our x is not x, it's sine of x. So it's 1 over your x, which our x is sine of x, times the derivative of sine of x. Kind of have to use like chain rule. So what is the derivative of sine of x? Positive cosine of x. So wait, I made a mistake here. On the top, it should be x prime. So what's the derivative of x5? 5x4. There you go. Okay, so my final answer is, so this would be 5x4 over x5 ln of 2, right? Now, is there anything else we can simplify before we write our final answer? Yes. Do you see this x4 divided by x5? That is x to the -1, because when you divide, you subtract, so 4 minus 1. So that simplifies as 5 over x ln of 12 plus, and then what simplifies as cosine of x over sine of x? Cotan of x. Okay, so this is your f prime. Okay, let's move on to example 3. Uh, we got to we have y equals x raised to the e raised to the sine of x. Okay, and we got to find dy dx. So it's a little bit of implicit differentiation. So what technique shall we use? Well, we have x raised to the e raised to the sine of x. So I might have to use the derivative logs. Wait, so on the right side, I will definitely use the derivative logs. On the left side, this is pretty easy. What is the derivative of 1y in respect to x? Uh, oh, no. So if we're going to take the derivative logs, there's only like really 2 steps. So step 1, take ln of both sides. Okay. And then step 2, so wait, so step 2, I would on the left side take the derivative because you can't really expand, right? So on left side, take the derivative, and then on the right side, use properties of logs to expand. Then I would take the derivative of each term. So let's look at the left side. So wait, let's do step 1. Take the ln of both sides, ln of y, ln of x e raised to the sine of x. Step 2, take on the left side, take the derivative. So what's the derivative of ln of y? That's logarithmic differentiation. So it's 1 over y times dy dx. And then before on the right side, do not take the derivative of this. Instead, do some expansion. So we have the power. So what happens when we have a power? When you're expanding logs, you put the power in front of the log or natural log. So this would be e raised to the sine of x, right? Because this is a power, right? This is like power. So it's e to the sine of x times ln of x. Then I would take the product rule. Now I got to take the derivative of this. So how do I take the derivative? What technique should I use to take the derivative? Well, there's two things that are multiplying. So you might as well use the product rule. This is not a constant. E to the sine of x is not a constant, so you must use the product rule. So my f will be e raised to the sine of x. My g is ln of x. Okay, f prime. The derivative e to the sine of x is easy. It's just itself times the derivative of the power. So it's e to the sine of x times the derivative of sine of x, which is cosine of x. And then on the right, what's the derivative of g prime? It's 1 over x. So let's see. Over here, if you want to put this in front, that's perfectly fine. So you could say cosine of x times e to the sine of x. And then you just apply the product rule. So f prime is this times g, which is ln of x, plus g prime, which is, what is g prime? 1 over x times f, which is e to the sine of x. Okay, so on the left, you have 1 over y of dy dx. And then on the left, what can I do? Maybe I could put this in front. I don't know if that will help. So maybe I could say e to the sine of x over x, plus, and then I'll put this on the other side. This, yeah, you could do that. Okay, now we got to solve for dy dx, so I have to get rid of this 1 over y. So how do I do that? By multiplying both sides by y. Okay, so this cancels. You're left with dy dx. Then you can replace this y with what is y, your original function, which is this xe sine of x. So that's what I'm going to do. So my final answer will be dy dx equals x e to the sine of x times it by e to the sine of x for x plus cosine of x We can just leave your answer like that. That's perfectly fine. So this is your final answer. Okay. So for this technique, I use what's called logarithmic differentiation. So why would I use this? Because you have like an e and then it's raising to the power. So that's why I did that. Let's move on to example 4. Or question 4, we have y equals x3 times 3 raised to the x, and we got to find y prime. So what derivative technique shall we use? Yes, you said it. Product rule, because there are two things that are multiplying. 3 raised to the x is not a constant, so yeah. Okay. So my f will be x cubed, and my g is going to be 3 raised to the x. F prime is 3x squared. G prime. What's the derivative of 3 raised to the x? Or what's the derivative of a constant raised to x? You're going to use this rule. So if you have a constant raised to x, just x, this is the rule. It's ln of a times a to the x times x prime. So my a, or my base, is 3. And then my x is x. So it's going to be ln of 3 times a, which is 3, raised to the x, times x prime, which is 1. So you could say, you could put this in front, so you can rewrite this as 3x ln of 3. Okay, and then you just apply the product rule, f prime of g plus g prime of f. That's it. So y prime is going to be f prime, which is 3x squared times regular g is 3 raised to the x plus g prime, which is 3x ln of 3 times it by at regular f, which is x cubed. Could you leave your answer like this? Probably, but more specifically, what can you do, or what can you factor? It looks like they both have a 3 raised to the x, and they both have an x. You could take out x squared because this is x2 and then this is x3, right? So you can factor out a 3 to the x squared, and then you have 3 plus x ln of 3. And here's your final answer. Okay, let's move on to example 5. We have x cubed minus y cubed equals y, and we want to find dy dx. So where most, we have what we're going to use what's called implicit differentiation. It's a little bit strange because you have this and then this, right? And then you have two y's, so you have to be careful. Differentiation. So basically, with implicit differentiation, you're taking the derivative of each term in respect to x, or time. So let's start with x cubed. So what's the derivative of x cubed in respect to x? Well, just don't worry about the implicit. What's the derivative of x cubed? It's power rule, right? 3x squared. So then what you have to do is you're going to put a dx on top. Why did I put a dx on top? Is because that is what your letter is. It's whatever your letter is goes on top. And then on the bottom, it's what are you trying to take it in respect of? We're trying to take it in respect to x. So I'm going to put a dx. But what do you notice? Dx over dx really cancels. So you don't really have to put this dx over dx because that just becomes 1. Now do the same thing with negative y cubed. What's the derivative of negative y cubed in general? it's power rule, right? So it's negative 3y squared. And then you're going to put a dy on the top because that is what our letter is. And then on the bottom, it's what you're taking in respect of x. So you're going to put a dx. And then on the right, this is like an invisible line. So the root of 1y is 1. And then you're going to put a dy on the top because that's what our letter is. And then on the bottom, it's in respect of taking it in respect to x. Okay, so we got to solve for dy dx. We have two dy dx. So what I'm going to do is, wait, let me rewrite this. We have 3x squared minus 3y squared. And then you don't really have to put that one. You could just say dy dx. Or you could put 1. It's up to you. So is this our final answer? No. We want it, and we got to solve for dy dx. So what I would do is anything that has a dy dx, get it all on one side. Anything that does not have a dy dx, get it on the other side, right? So I'm going to move this negative 3y squared dy dx to the other side. So this cancels. So we're left with 3x squared equals to 1 dy dx plus 3y squared dy dx. And then what you could do is now you see why we did this is because now we can factor out a dy dx. So go ahead and factor that out. And then you still have this one here plus then you have this 3y squared. And then on the left side you have 3x squared. Is this our final answer? Almost. Now we got to solve for dy dx, so I got to get rid of this 1 plus 3y squared. How do I do that? Since this is multiplication, the opposite of multiplication is dividing. So you're going to divide everything by itself, 1 plus 3y squared on both sides. Okay, so this cancels. And then our final answer, you could put the dy dx on the left side. It doesn't matter because of the commutative property. And then you have 3x squared over 1 plus 3y squared. Okay, so this is your final answer. Okay, well, let's move on to example 6, or question 6. So we have 6 equals y equals arc, then a square root of x, and we got to find y prime. So what technique shall we use? Okay, so arc sine is basically the inverse, right? Arc, whenever you see the arc, it's like saying inverse. So you're taking the derivative of the inverse. So what is that rule? It is, so the derivative of d over dx of arc, then let's call this u, is equal to u prime over square root of 1 minus u squared. This is something you should know. This is something you should know. So the derivative of sine inverse or arc sine is u prime over square root of 1 minus u squared. So what do you think our u is going to be? Yes, our u is going to be square root of x. And then what do you think our u prime is going to be? That is correct. It's going to be 1 over 2 square root of x. So we have everything we need. We just put it in the formula and we are good. So you could say y prime is equal to u prime. So it's going to be 1 over, because u prime is a fraction, so I'll put that here. Let me put u prime. It's going to be right here. And then it's going to be 1 over square root of 1 minus u squared. My u is radical x, and I got to square that. So if I clean this up a bit, this is going to be 1 over square root, and then square root of x squared, that's what happens when you square radical, it disappears. So you're just left with 1 minus x times your u prime, which is 1 over 2 square root of x. If you clean this up a bit, it's going to be 1 over, and then you may put this 2 radical x on the left side. These do not combine, even though they have a square root. It doesn't disappear. Why doesn't it disappear? Because these have to be the same. They're not the same. So you could say 2 square root of x times square root of 1 minus x. That's it. Okay, let's move on to 7. So 7, we have f of x equals sin of cosine square root of x. So we got to find f prime. So what shall we use? It's not product rule, it's chain rule. So f prime. So first you got to figure out what the derivative sign of x. That's part of the chain rule. So it's the derivative sign is cosine, and then this is your x. This whole thing is your x, so just leave it as it is. Times the derivative x prime. So what if this is whole things are x? What's the derivative cosine of square root of x? It's like literally the chain rule again. So what's the wait? So x is cosine square root of x, and then x prime is negatives. Well, the derivative of cosine is negative sine the square root of x times the derivative of square root of x. What's the derivative of square root of x is 1 over 2 square root of x. So this is going to be the derivative of cosine square root of x is negative sine of square root of x over 2 square root of x. Okay. So if you do clean this up, f prime x, so you let's see what we have. We have this invisible negative 1/2, so you can put that in front. Cosine, and then we have a fraction. And if you really want to clean this up, you can rewrite this. This would be your final answer. Negative cosine of cosine square root of x times sine square root of x all over 2 square root of x. Okay, so this is your final answer. So yeah, this technique is called the chain rule. Let's do another one. Let's move on to question 8. So 8, we have y equals 1 plus tan of ln of x over 1 minus tan of ln of x. So and we got to find y prime. So what technique shall we use? Yes, we should use the quotient rule because it's in a fraction form, right? So if you recall, that quotient rule is f over g prime, which is f prime of g minus g prime of f all over g squared. Okay, this is something you should know. So what is our f? Our f is the numerator, so it's 1 plus tan of ln of x. And then f prime, the derivative of 1 is 0. What's the derivative of tan of ln of x is, well, the derivative of tan is secant squared of x, and our x is like ln of x, times, then you apply the chain rule. So what's the derivative of x, or the derivative of ln of x? The derivative of ln of x is 1 over x. So your final answer is going to be secant square of ln of x all over x. And then your g is the derivative of the denominator, which is 1 minus tan of ln of x. So my g prime, the derivative 1 is 0. The derivative negative tan of ln of x is like chain rule. So the derivative of negative tan is negative secant square of x. And our x is like this ln of x. Times, then you apply the chain rule. So the derivative of ln of x is 1 over x. So if you clean that up a bit, you get negative secant square of ln of x all over x. And then you just apply the quotient rule. So you could say y prime is f prime, which is secant square of ln of x all over x, times the derivative of blah, 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 g, regular g, is 1 minus tan of ln of x minus bracket continue g prime is negative secant square of ln of x all over x times it by f, which is 1 plus tan of ln of x all over g prime, which is 1 minus tan of ln of x. I mean, g squared. That's what I meant. What do we have? We have what's called a complex fraction. So let's fix the numerator a bit. So y prime, if you clean up the numerator, it's going to be like this. Secant square of ln of x times 1 minus tan of ln of x all over x. And then over here you have two minuses, that becomes a positive. So that's going to be secant square of ln of x times 1 plus tan of ln of x over x. The good news is, okay, so this whole thing is your numerator. The good news is you see this x, that's good. So over here, yeah, you can, this whole thing is your numerator. The good news is they both have a denominator of x, so you can write it as one single fraction. Okay, we have a complex fraction. So you could do the bracket method. Oh wait, so careful. This whole thing is your numerator. This whole thing is your denominator. So this has a 1. So I'm going to do the bracket method. I'm going to multiply. So on the numerator, our denominator is x. And then on the denominator, our denominator is 1. So the LCD will be x. So you're multiplying the numerator and the denominator by x. So over here, when you multiply the x cancels. So you're left with y prime equals to secant square of ln of x 1 minus tan ln of x And then over here, when you multiply the denominator by x, it's just x. So it's just x times itself. Okay, so this is your final answer. Okay, I'm going to stop here. So this is part 1, and we'll continue part 2 on question 9. Let me put a star, and yep, I'll stop right here.